Now, Earth Day is coming up here a little later this month, and over the course of the month, we've been taking an effort to highlight some of the ways that the International Space Station Science Program is adding to the body of knowledge about our planet. That includes a number of different cameras that are pointed down at the planet, many of them gathering very specific kinds of data. One of them is an experimental camera system known as ISERV, and it recently finished its first year of operation. The payload developer and principal investigator is Burgess Howell at NASA's Marshall Space Flight Center, and he joins us this morning from Huntsville, Alabama. Burgess, you've described this as an experimental system. What's the experiment here?
Well, Pat, as an Earth-observing scientist, we see ISS as an interesting platform for various methods of Earth observation, covering various portions of the electromagnetic spectrum. We're interested in, for instance, visible and near-infrared, mid- and far-infrared, and even microwave radiation. As opposed to what most people may be familiar with in terms of NASA's efforts with Earth observation, the most commonly known would be like the A-Train satellites, Landsat, EO1, those guys. ISS has a very interesting orbit, and it allows us to see things on the Earth from different locations, with different sun angles, different view angles, and allows us to be sort of a calibration and validation source for a variety of other instruments that NASA and other agencies have flying. So Pathfinder is a low-cost, high-return-on-investment means for us to develop the processes and procedures and to gain experience and expertise in Earth observation from the International Space Station in order to pave the way for future and more capable instrumentation.
Tell me where the genesis of this for you, this specific kind of camera. Where'd that come from?
Well, let me give you a little background. We're part of a project called SERVIR, and I'll inflict my bad Spanish on you here for a second. It's the Sistema Regional de Visualización y Monitoreo, which translated into English is the Regional System for Visualization and Monitoring. We utilize the existing assets or assets from other sources, other agencies, to provide science-based applications and tools that will assist those who might make environmental decisions, primarily in the developing world. We operate mostly in the Global Earth Observation System of Systems Societal Benefits area. There are 9 of those: health, energy, water, ecosystems, agriculture, etc. And one of them, in particular, disasters, looked like a place where we could provide some tangible and valuable results while accomplishing the test bed goals that I mentioned before of gaining the expertise and experience to provide the information for future instrumentation systems.
And we are going to show some pictures here in a minute, but before we do, describe the camera equipment that's in use for ISERV and just where on the station it's located.
Yeah, sure. Well, first we operate in the Destiny module. That's the science module there. There is a high quality Earth-facing window, about 20 inches in diameter, through which we are able to see the Earth. We're in a payload. Volume there called the Window Observational Research Facility, WARF. Mm-hmm. It's essentially a light-safe box, a dark box that allows us some mounting provisions and some connections to the infrastructure there, power and data connections, so that we can hook up the hardware and the computers that are required to run the system and look out through that window down at the Earth and make our observations.
And shooting through one of the best windows, too. Shooting through one of the best
windows.
Beautiful.
It is just about the best glass you can get. It's beautiful. It's extraordinarily high quality, virtually distortion free, and it suits our purposes very well as the purposes of other instruments that come behind us here. The system is based on commercial off-the-shelf hardware. It's the 2 primary components are a commercial digital single lens reflex camera and a 9.25-inch aperture astronomical grade telescope, again, commercially obtained here in town. We do have some modifications, some physical modifications to the system that improve our position, within WRF, and they also help our pointing geometry, make us better located with respect to the window so that we can see a broader field of view there. Plus, we have some other custom mounting beds, power and data connections, things like that.
Now, are the crew members on orbit taking these pictures, or are you taking them from the ground?
No, the system is all entirely remotely controlled from our Science Operations Center here at the National Space Science and Technology Center. We're affiliated with Marshall here in Huntsville, Alabama. It's driven by some custom software that was developed here at Marshall, and we have the option to operate it in real time by sitting there and watching the Earth go by underneath us and pushing the buttons as necessary, or we can run via a timed command system, which is our primary method of operation. It allows us to pre-plan our shots. We just tell the camera when the target of interest is coming by, what time it needs to swing over into the right position to acquire the images. The station goes over and it takes the images and stores them on board for us. We then do the downlinking here at Marshall and do the basic command processing, the data processing before we archive and distribute the data sets. The crew actually don't have any involvement except for helping us with a few hiccups, and we have had a few as we've operated. We had a fairly significant pointing problem back last summer, and Koichi Wataka was one of the fellows who helped us out earlier this year in getting our system repaired and back up.
Let's take a look at some of the pictures that you're getting. You provided us with a little sampling, and we'll put the first one up on the screen right now. You describe what we're seeing here. This is part of Mongolia, right?
Yeah, this is the southwestern edge of the shore of a lake called Ulfsnur. It's in Mongolia. It's very interesting from our point of view. Remember, we look at things from environmental decision-making point of view. This is the center of a very delicate and very important area of biodiversity in Mongolia. The lake itself is interesting because it's endorheic. In other words, there's a flow only into the lake. There's no flow out. The basin around it flows in. This causes a couple of things. Number one, and most importantly, it increases the salinity of the lake. The lake is about half as salty as ocean water, but it creates a very diverse landscape around it. And you see in this image here, a lot of these bright spots, these are actually salt deposits as the lake recedes, as it evaporates, and it is evaporating away. It's one of the reasons why we're interested in it. We're looking at how the region is changing by the evaporation of the lake, but those salt deposits left behind there are kind of interesting to look at.
Sorry to interrupt. I've jumped ahead on your list. I put up this picture of the Grand Canyon because I found that to be really amazing. Can you describe what we're seeing in that picture?
Sure. Grand Canyon is one of the great geological formations of the world, and it's part of the continent's physical and cultural heritage. And we were very happy to get this image of it back last spring. What you see here is a shot that's very near the Grand Canyon Village. It's unfortunately just out of frame, lower left, but at the very bottom, I think you may be able to see there the parallel paths of the Rim Highway and the train that go into the Grand Canyon Village. Of course, through the center there is the Colorado River that is responsible for carving the landscape through the Grand Canyon there, and it's a fascinating piece of geology. I have a little bit of geology background, and I really enjoy looking at this stuff. Just near the center there, just off center to the bottom, that's the trailhead for the South Kaibab Trail. One of the very popular trails that goes down into the canyon itself.
And we have time for one more, and I want to get you to talk a little bit about the fact that sometimes you get called in to help to do work after disasters take place. You showed us a couple of pictures that you shot of where a tornado hit in Moore, Oklahoma. Yeah,
Moore, Oklahoma, of course, back in May of last year, there was the devastating tornado that ripped through Moore and killed 24 people, and it was a horrible, tragic event. We were asked to do some imaging in the aftermath to document the path of the storm through Moore there. As you can see running diagonally from lower left to upper right, that's the interstate that goes through the middle of town there. Just just to the upper left of that is where Plaza Towers Elementary stood. It was the site where those 7 children were killed. But we did this as a collaborative effort here with another group at Marshall that operates in looking at near real-time weather forecasting, and they also look at the effects of severe storms primarily in the United States, but in other parts of the country as well.
Those are amazing pictures, and I think it's great to see those kind of things. Burgess Howell, thank you for taking some time to tell us about ISERV and what it's doing on board the space station.
Thank you, Pat. We appreciate the opportunity to talk to you.
Burgess Howell is the payload developer and the principal investigator for the ISERV payload out of NASA's Marshall Space Flight Center in Huntsville, Alabama.